Okay, so attendance is coming around. Just a quick recap. So notes will be posted here on Moodle, so that information is there. I'm going to let that be. Leave that be. All right. So today we're going to move into section 1-2, applications and modeling with linear equations. So we're just going to continue the discussion of linear equations. This stuff is kind of straightforward on solving an implied problem. Just typically you want to read the question. You might have to read it several times. Assign a variable to represent your unknown. Maybe organize the data and draw a picture. So you want to organize it, either draw a picture or create a chart or a label or something of that nature to organize the data. Write an equation using the variable in an expression. Solve it. State the answer. Ask yourself, is this answer reasonable? Does it make sense in the context? If we're talking about the speed of a car, did we get thousands of miles per hour? You don't want that. You want a reasonable result. And then check it in the words of the original problem as best you can. Don't want to see the solution just yet. All right, here's an example of finding the dimensions of a square. It says the length of each side of a square is increased by 3 centimeters. The perimeter of the new square is 40 centimeters more than twice the original square. Find the dimensions. Okay, let's get, let's paste. I want to paste the blank page there. But I don't want to see the solution. We're going to get a copy of this. And I'm going to drop this here. So this is just a reference for us to kind of ping pong back and forth. All right. So attendance should be coming around. Anybody else needs to sign the attendance? This is a good one. Go ahead. Question? Okay. All right. So let's look at this again. It says the length of each side of a square is increased by 3 centimeters. So let's look at this again. It says the length of each side of a square. All right. Yeah. Okay. We're good to go. So with this discussion, what do you think would be the proper thing to do first if we want to organize this data or get a sense of what's going on? I heard the draw. Let's draw a picture. Let's draw a picture to put it in context. What's the basic shape here? Give me your favorite color. I heard blue today. That was the first one I heard. I want to do a figure. I want a square. I want the field to be empty. I heard blue. What color is indigo? Do you see it up there? Violet. We'll get it. There. Okay, I'll do it like this. I want a crop. I thought I had my notifications off, but that's okay. All right. So we have our square. Now, it says the length of each side of a square is increased by 3 centimeters, right? So then, what are we doing? What's happening?
It's adding.
Okay, yeah, so we're adding or increasing the length of the side, so I'm going to have another square. I want to edit. Actually, and okay, her indigo.
So do that like that.
This one?
Next to it. Or
This one? This one?
Yeah.
That one?
You can do the one that's, no, go down. That one or the one below that one.
Below. Oh, I'm going to do this one.
That one is pretty. I like that one.
Okay.
Indigo is like a mixture between those two colors.
Okay. You learn something to do every day. I want to get rid of this other one though. Or can I change it? Let me see something. Just delete it. And I'll just make a new one. So there, this, we said this. And then we want a square. I'm going to go like this and kind of eyeball that.
Is that not a pretty color though?
It is. I will give you that. I would call it navy blue, but...
No, that's what I'm saying. Indigo is a mix between this one and the other one I was trying.
I see. I see.
He said I would call it navy blue.
Oh, well, I mean, potato, potato. Okay. All right, this looks better. Okay, so it says now, we have the length of each side of a square is increased by 3 centimeters. Okay, it says the perimeter of the new square says find the dimensions of the original square. So what's our unknown here? Yeah, so we're going to let this be x, right? So now, when we go from the original square to the new square, how can we describe the side? X plus 3, right? So let's do that in, I think it was this one. We're going to say x plus 3. Y'all got some delicious smelling food. No, it's not Skittles. It smells like chicken or something. Yeah, I can smell like chicken. It's like, man. You got to bring enough to share with everybody. But no, it's okay. I feel bad now because I'm on the internet advocating for chicken, and I feel some kind of way about chicken in public. I just feel some kind of way. But that's neither here nor there. Okay, so it says the length of each side of the square is increased by 3 centimeters. It says the perimeter of the new square is 40 centimeters more than twice the original. Okay, let's capture that. So the perimeter of the new one is, what's next? So 40.
Okay, so the perimeter
40 centimeters plus.
No, it's x, 2x plus 40.
Okay, and we're gonna say 2 times x, right? Let's make sure. It says the perimeter of the new square is, and here, give me another color.
Do the purple one.
Purple. I'm gonna do this purple.
These colors are different.
All right. So it says the perimeter of the new square is 40 centimeters more than twice the original length. Everybody see that okay? All right. So I just translated it verbatim from English to symbols. Yeah. Okay. So that looks good. Let's see what else do we have. It says the length of the each side of the square. The perimeter of the new square is 40 centimeters more than twice. Find the dimensions of the original. All right. Oh. Okay, one more. Do we have more information that we can fill in? Okay. What would you do next is what I'm asking. So we have something on.
Trying to figure out what x is, ain't it?
Yeah, we want to solve for x, right?
But
so
that's not the perimeter. You just trying to solve for x to plug it in, right?
Okay, yeah.
Sorry.
No, you're good. So I'm just curious as to what would you do next?
Subtract 40 and divide it by 2.
Okay, wait. But before we can do that, we have 2 unknowns right now. So can we fill in for one or the other? We have a p and we have an x.
Right, so we have to figure out what x is first.
What were you about to say? Can we talk about the perimeter of the new square? What's perimeter? What? Okay, wait. So here's my next question. Is perimeter a formula, a set formula, or is it more of a concept? It's more of a concept. What does perimeter mean? The distance around, right?
It's x plus 3 4 times.
Right. Exactly. That's the whole point. Yeah. So here.
So that's going to be on the other side.
There you go. Let's copy. We want to paste. So that's there. This is also here. It's also here. And it's also here, right? So if we want the perimeter of the new square, we're going to say that left. Where's my cursor? It's gone. No, it's gone. We did this. So we're going to say, let's copy this. So when we talk about the perimeter of the new square, we're going to say this plus this plus this plus this. So something added to itself 4 times is the same as what? Yeah, multiplying by 4. So now we got that the perimeter is 4 times x plus 3, right? So now let's put these 2 ideas together. So we have that the perimeter is 4 times x plus 3, but we also have that the perimeter of the new square is 40 plus 2x. Let me just copy this. Copy. Paste. All right. So then what can we do with these 2 equations?
So that's, you put one on each side.
Yeah, we set them equal to each other. So then it should be the case that 4 times x plus 3 equals 40 plus 2x. Now, at this point, we have 1 equation, 1 unknown. Now we can solve. You should be able to take it from here. Anybody got a result already? Where's my attendance? Anybody else needs to sign attendance? What's the last? Yeah. Because what time is it? It started. That's not right. Why does it always do that? It shows 9:41 for some reason. I'll give her another 5 minutes. Okay. There we go. Speak of the angel. Attendance. So, this comes out of attendance. Anybody get a result? With 15? Thank you. All right, so one of the claims is that x equals 14. Well, let me see what happens. So if I were to do this, I would distribute, right? And I'll continue in purple. So then I'm gonna get 4x plus 12 equals 40 plus 2x. I'm gonna isolate my variables and move my constants to the other. So I'm gonna get 4x minus 2x. I'm going to get 40 minus 12. Any questions on what I did there? Okay. I subtracted 2x from both sides. I said minus 2x, and I also did minus 12, minus 12. I just kind of skipped that a little bit. All right, so then we combine like terms. We get 2x, 30, 28, right? Then divide by 2. And I can agree with x equals 14. Now, what does this mean? We're saying that x is 14 what? Centimeters. So our claim is that x is 14 centimeters. We just need to do our best to see if it makes sense in the context of the original. So we're saying that this one is going to be what, 14 plus 3, which is 17 centimeters. Let's see. It says find the length of each side of a square. So we went from 14 to 17. It says the perimeter of the new square is 40 centimeters more than twice the original length. So if we say the 2x plus 40, 17 and 17 is what? 34, 54? Is that 54? And then 7. I'm just saying, does 14 work in the context of the original? Our claim is that the perimeter of the original is what, 54? Is that right? No, that's not right. Hang on. 14 and 14, 28, 68, right? Is it 68? Yeah. And then, is that the same as 17 times 4? Yeah. Okay, so it works out. Okay. And I think we actually have it worked out already here. We drew the picture. We got the same picture. We did that. 14. Okay. All right, and we just made sure that it made sense in the context of the original question. Go ahead.
You said y'all have tutoring, right?
Mm-hmm.
Y'all have
Yeah. There are tutors here on campus. You might want to email the department chair. I can actually help with that too. If you like, just send me pictures. I can do it here as well. So I can help with calculus, but we actually have tutors here on campus as well. Yeah, just send me a picture of your math question. Type it in an email like, hey, I was working on this, and here's an image, and I'll just load it like this and stream it and send you the link. So that's why you want to be subscribed with your notifications on. Go ahead. Yeah. So like the same way I'm live right now, I'm proficient from about calculus 3 on down. A little bit of like some others outside of that, but calculus 3 on down, I'm fairly decent. Go ahead. My math lab? Yeah. Remind me when we get closer to when we leave. Or either send it to me in an email. Okay? All right, let's keep going. So, motion problems. So, in this one, we're typically, when you're driving, like, say you're on a highway, and what are the units for speed limit in America? Miles per hour, right? So, miles is distance, hours is time. So the rate is, and yeah, let's just see how it comes about. Now these can be a little bit tricky, but we'll do the best that we can. That stuff smells so good. It's awesome. Okay, Maria and Eduardo are traveling to a business conference. The trip takes 2 hours for Maria and 2.5 for Eduardo. Since he lives 40 miles further away, Eduardo travels 5 miles per hour faster than Maria. Find their average rates. Okay, so I usually like to kind of go about this one in this kind of manner. First, what would you do first to organize the data? Okay, we could do a formula. What did we do last time first? Let's draw a picture just to get a sense, right? So what's going on? We have, right? And then say this is Eduardo, right? Say this is Maria. I'm just getting a sense of what's going on, right? Would you agree? Okay. So it says Maria and Eduardo are traveling to a conference. The trip takes, so the time for Maria, so I'm going to label it like this. I'm going to say time for Maria is what, 2 hours, right? And 2.5 for Eduardo. So the time for, I'm going to do like this. Eduardo is going to be 2.5 hours, right? The distance, well, Eduardo's 40 miles further than Maria. So I'm going to say the distance for Maria, I'm just going to leave it as DM. Or you can call it D, whichever floats your boat. For me personally, I prefer this. Keep the label. So I know that DM is talking about Maria's distance. But then if we talk about Eduardo's distance, right? What do we know? It's going to be, so it's going to, yeah. So how can we capture that with this information? To add 40 miles to who? No. It's 40 miles further than who? To Maria.
So 40 plus DM.
Yeah. So we're gonna say Maria's distance plus 40 miles, right? Let's see. And then the rate. So then, no more space. So we're gonna say Eduardo's rate. Do we have any information on Maria's rate? It doesn't say anything? No? So Maria's rate, I'm going to just leave it as RM, right? But Eduardo's rate is going to be Maria's rate, what? Plus 5 miles per hour, okay? So let's do the following. We're almost there. Where is, let me bookmark this. Yeah, hang on. I want to copy. So give me one moment. Let me see if I can articulate it properly. I'm going to clear. All right. So let's do the following. We said that what? Distance equals rate times time, right? Agreed? So then we're looking at two people. We're looking at what? Maria and Eduardo, right? So let's do like this. And then we'll go like this. And we'll put a double bar so we know that that's the equal. We're going to separate this. And we're going to go like this. All right. And I'm not liking that last line. And let's do right there. Okay. So now let's see if we can organize this data. Let me do one other thing. I'm going to move this guy over here. And I'm going to move these this way. I'm going to move this goes here. I'm going to move this here. Like that. Okay. So now let's see if we can organize this data. And just being nitpicky at this point. Just doing it because I can. All right. Now, let's see if we can organize this data. What is the question asking us? It says find their average rates. So what's going to be our unknown in this case? The rate, right? Okay, so it seems like the only thing we don't have information on is Maria's rate. So I'm going to let her rate be R. I'm going to let that be our unknown. That's fine. So we're going to let hers be our unknown. What's her time? 2 hours, right? So Maria's time is 2. So then her distance should be 2R, right? So I think that was fine. Is that okay? Now, can you tell me about Eduardo's rate? We said 5 more than Maria, so R plus 5. Is that okay? Eduardo's time. So his distance should be 2.5 times R plus 5, right? Maria's distance, Eduardo's distance. Oh, and then what can you tell me about their two distances? How can you compare? What comparison do you have about Eduardo's distance in comparison to Maria's distance? So Eduardo's distance, which is the bottom one, is 40 miles more than Maria's, which is the top one, right? So Eduardo's distance, which is this 2.5 R plus 5, is equal to Maria's distance, which is 2 times R, what? Plus 40. Does that make sense? Now we have one equation, one unknown we can solve. We should recap that. That takes a little bit. Now, only reason I knew to do all this is because I've seen it time and time again, year after year. You know, it's not obvious. It's not obvious to do it this way. The way I've done it in the past is what you see at the top, but I know that confuses the students. And this table is, I feel like, a better presentation. Say that again. Because the text says that Eduardo lives 40 miles further away, so he travels 40 miles more than Maria. Okay, yeah. Okay? You see it? Because Eduardo's distance is Maria's distance plus 40. Yeah. You'll see that. Give me a color. I was thinking green too. They say geniuses pick green. I agree with you. I like this green too. All right. But yeah, it's so, you know, we just kind of went line by line and tried to find some kind of way to incorporate each piece of information. But then ultimately, I think the table is the best way to display the information. Rate times time equals distance. Maria's rate was our unknown. That's the only thing we really didn't have any information on. They gave us her time, so her distance is going to be 2R. Eduardo's rate was Maria's rate plus 5. His time was 2.5 hours, and his distance was rate times time. So you see it expressed there. But then it also tells us that Eduardo's distance was Maria's distance plus 40. Once you synthesize all that information, we get this. Now we have one equation, one unknown. Where's my attendance? Anybody else in society attendance? I got 2, 4, 6, 8, 10, 12, 13. 2, 4, 6, 8, 10, 12, 13. The first person that can tell me, I can maybe give you some extra credit. What's the technique that we have to get rid of decimals? I got to see a hand. How do we? If I wanted to get rid of the decimals on either side, what do we do? How do we get rid of the decimals? Hand, any? Right here, do you have it? No? No? Not percent. Not factor. What were you saying? Close. She said it. She got it. She got it. Tell me your last name. All right, so she got it. So remember last time we said let me see, clearing decimals question. Okay, so last time I think we talked about the multiplication property of equality. We can multiply the same non-zero number on either side of the equal sign and preserve equality, right? 10 is a non-zero number. So the largest decimal here is 1 decimal place. So the appropriate power of 10 that we need on either side is 10. If the largest decimal, say, were 3 decimal places, we would multiply the left and right by 1,000 to clear the decimals. It takes practice, though. because the parentheses do kind of confuse things a bit. So you don't have to do that. I just want you to be aware of it. I just want you to be aware of it. I'm going to do it. I like to do it because the decimals, I tend to make more mistakes when I keep the decimals in power. Let me kind of finish this out, and then I'll entertain the question. So on the left, so what I'm going to do is say the left side by 10, and I'm going to say the right side by 10, right? Now, when we say the left by 10, it's just this guy. It's called the associative property of equality, of multiplication. But on the right, I got to distribute. It's multiplication over addition. So that's why I say it kind of confuses students sometimes. It takes practice to be able to do this properly. When we do this, we'll get the following. Is it still there? It should still be there. That's fine. And I'll clear this. Okay. So when we do this, we'll get the following result. We'll get 25 here. This stays the same. This becomes 20R. This becomes 400. Now we have one equation, one unknown, no decimals. It's much easier to solve. Anybody get a result for R? If anybody gets the result before me, I might be able to give you some points. We're going to race now. I gave you a little bit of a head start. Whoever can get it before me correctly, I might be able to help you out. So 25R, 125, 20R, 400. Still on the board. I get 5R, 300, 275. Points off the board. It's off the board. That's a 525. I got it. Miles per hour.
That's not fair.
So the thing about opportunities don't go away. They just go to who's next, as one of my mentors would say. They don't go away. They just go to who's next. Okay. So now, I'm not saying this is right. I'm saying this is, when I crunch the number, this is what I got. So then you just want to go back and see, does it make sense in the context of the original? So if Maria's rate is, and I mean, there was a way where even if you didn't crunch it really quickly, you could have gotten it even faster, but then I was going to challenge you. You know, there are ways. There are always ways. But anyway, so now our claim is that Maria's rate is 55 miles per hour. So then we're saying that what Eduardo's rate is what? 60 miles per hour, right? So this is our claim. So does this make sense? What's 55 times 2? 110, right? Is that right? So the claim is that Maria travels 110 miles, right? So then that means Eduardo should travel what? 150, right? 40 miles more. He should go a distance of 150. So if we say 55 plus 5 is 60, 60 times 2.5, 60, 120, 150. It works out. Okay? So this result does make sense in the context of the original. Okay? Any questions here? I feel like there should be some questions. Did you win something?
No.
It's your birthday. Oh, happy birthday. Okay. What is this, January? So we're in Capricorn?
Yes.
Okay. All right. Well, happy birthday.
Thank you.
Any questions here before I go forward? So you won the game of life, the race. Not to get like vulgar or anything, but they talk about like, you know. They say that like when the child is a woman, they say that the semen is stronger, but if it's a man, then it was faster. I don't know, because I said the race of life, so it made me think of like the egg swimming to the egg. Then that's what they say. It says that if it's a girl, then it was a strong, and if it's a guy, it's supposed to be faster. I don't know what that means. But then any other more? Okay, so let's look at it. So yeah, we did this. We read the question several times. We assigned a variable. They called it X, we called it R, but we got the context. We essentially got the same thing, and then this. And I think we get the same result. And then we stated the answer, and then we checked it in the context of the original. Okay, questions, comments, or concerns? All right, I'm going to keep moving. All right, so the mixture problems.
This is not bad.
Yeah, this is okay. But it takes practice. Don't get lulled into a false sense of security. You just want to make sure that you're getting these right on a consistent basis. So be sure to get some practice in. We might get some practice in. I'm trying to watch the clock. I know my clock here. I don't know why it jumps to that default when I'm on this setup, but I have a clock here. So go ahead.
What is the aux stand for? Like, what is rate? When you say rate,
It's rate is the change in distance per unit time. So how the distance changes for each unit of time. So like if you're traveling 55 miles per hour, that means every hour you go what distance?
55.
There are videos on the internet. It's like the blonde moment where it's a boyfriend and a girlfriend and they're driving cross country and the boyfriend asks the girlfriend, he's like, if you're traveling 65 miles per hour, how far will you go in 1 hour? And she's like trying to calculate all this stuff, you know. Yeah, but she won't just say that. Like it's a number of videos out like that. So that's neither here nor there. But yeah, so rate is the change, how the distance covered per unit time. That's what rate means. All right. So mixture problems. Problem solving hint. In the mixture problem involving solutions, the rate of concentration is multiplied by the quantity. Okay. So long story short, with mixture problems, I usually do the following. Give me a color.
Green. No. Purple.
I heard green first. But since I haven't used pink, I'll use pink. All right. So, but mixture problems, I usually do the following. I'll say percent of substance 1 times the amount of substance 1 plus percent of substance 2 times the amount, whatever, of substance 2 equals the final percent times the final amount. So when I do mixture problems, I usually have that set up.
Oh, so you put the words into the numbers?
Pardon?
You put those words into the
No, I'm just saying when I work mixture problems, I usually use that pink formula there. Let's see it in action. All right. So here, it's gonna come right back. So it says Lisa is a chemist. She needs a 20% solution of alcohol. She has 15% on hand, as well as a 30% solution. How many liters of the 15% should she add to 3 liters of the 30 to obtain her desired result? So scratch that again. Mixture problems, all I do is the following. Again, percent 1 times, I'm going to put a hashtag for amount 1, plus percent of substance 2 times the amount of substance 2 equal the final percent, I'm going to put percent F, times the final amount. That's all that I'm doing, right? So now let's go back and read. She needs 20% solution. So where does that percent go? Percent 1, percent 2, or percent final? Final. If she needs the 20%, she wants to finish with 20%, right? So if she needs it, go here. So she wants to finish with 20%, so that goes here. She has 15%. So where can that go? Okay. So then 15% can go here. She also has 30% on hand, so we'll put that in the second one, right? How many liters? So if it says how many, that means that is our what? That's our unknown. So we're going to label that as X under which one? It says how many liters of the 15? So it goes right here, right? Plus. It says how many liters of the 15 should she add to 3 liters of the 30? So where does the 3 go? Number 2, 3 liters. And so now, if she has X liters, if we're gonna get X liters plus 3 liters, how many liters does she have in the end? Not 3 times X, 3 plus X. Does that make sense? So we're gonna say X plus 3. Is that okay? Now we have one equation, one unknown we can solve. The percent symbol, you can look at it as per 100. Come on, per 100. So all those percent symbols, so like this guy this one, and this one. Oh, just missed it. Here, that one, that one. All of the, oh, I think I still make the same mistake. Sorry. This one, and just get all the way back there. We're gonna make that green. Yeah, I just missed one. I missed two, but that's okay. That X liters, yeah. So all those percent symbols you can rewrite as times 1 over 100. So if we divide all those by 100,
Oh my god.
yeah, I can't. No, I just had the wrong thing selected. All right, so let's see. We should be able to paste. And I want to clear. Okay. So now we have one equation. So now if we divide all of those by 100, what happens? Yeah, they turn to decimals. Yeah. So they'll become 0. So we have 0.15 times x, 0.3 times, I'll go ahead and put that times 3. Yeah. 0.2 times x plus 3. But then, just last time we said, to get rid of the decimals, what do we do? But in this case, it'll be 100 because it's 2 decimal places. And so you'll see quickly what happens. So if we say the left by 100 and the right by 100, ultimately, we're going to say that, and then this one. Ultimately, we're going to get 15x plus 30 times 3 equals 20 times this. Now we have one equation, one unknown we can solve. Okay? And no decimals and things of that nature. Essentially, with these, you could just drop the percent symbol. But, you know, what I showed you was the proper way to go about it. Okay? So now, hopefully, you might already have the answer before me. Or you might beat me. We're going to do another race. So, hopefully, because you should be able to take it at this point. So, you know. That's why it's a good idea to work these out before coming into class, because I do stuff. Oh, 2. Okay, we got a claim. First claim. Tell me your last name. Webb, right? Yeah. Okay. So we have our first. What's your favorite color? All right. So we got a claim that x equals 2. Let's see. So this is for Ms. Webb. Let's see if it works. I'll do mine. I'll do blue. I'll do green. What color haven't I used?
Brown, gray, white.
I don't want to do any of those.
White. Why in the world? Why did you say you had these colors?
All right, I'm gonna do this one. I got a color. Okay, so I'm gonna finish it out. All right, so we got 15. What is that? 90, right? We get 20x and 60, right? I'm gonna isolate my variables on one side, everything else to the other. I'll go ahead and write out what I'm doing. So I'm gonna say minus 20x on both sides. Actually, did she make a mistake?
Yes.
Uh-oh. Oh, wait. What's your claim? 6. Okay. What's your color? Green. Like this one? Yeah. All right. So the second claim is for 6. Let's see what happens. It's okay. But this is, you want to have speed and accuracy, but then you got to check and, all that kind of stuff. I'm going to make a change, though. Instead of subtracting the 20, what I'm going to do, subtract the 15, so that way I'm not dealing with negatives. Then I'm going to move the 60, right? So let's do this, and then back to my original. So then that goes to 0. That goes to 0. That's what? 5x, right? Come on. And then what's that? 30. So the x, I can agree with 6. So that's okay. Happens. Who's the green? What's your last name? James. It's James. Okay. That's okay. Again, opportunities don't go away. They go to who's next. So now, I got the same thing as 6 liters, but we need to check it in the context of the original. So now the 6 liters work. So here, what I'll do the following. If we plug 6 in, should it make it true or should it make it false? True. All right, so let's see. Let's check that 2 first. So where we got 2 liters before, let's just check and see if that works. So we want to reload and refresh. What's the time? We get out So about 1 o'clock, we're going to change the rhythm. We're going to change up a little bit. All right. So now, okay. Now, when we plug these solutions into the original, should it make it true or should it make it false? It should make it true, which means the left should equal the right, right? If the left is going to be equal to the right, if I say the left minus the right, what result should I get? I should get 0, right? So let's see. I'm going to go to y equals. I'm going to do open parentheses. I'm going to say my 0.15 times x plus 0.3 times 3. That's my left. I'm going to say minus the right, which is 0.2. Open another set, x plus 3, and double close, right? So I essentially said the left minus the right, right? So now I'm going to go to, you see the clear button, you see variables right there, the VARS. I'm going to click on variables. I'm going to go to the right to Y variables. I'm going to click number 1. I'm going to click number 1. Now I want to check that 2 really quickly. Now, we know that 2 should be wrong. So should I get, what kind of result should I get here? Something that's, so if it's false, what should happen? We should get something other than 0. Let's see what happens. We got something other than 0, right? So that's an indicator that we made a mistake. That's a quick way to check. So, okay, so that should be a hint that 2 was not right. So then we went back and did it again. We found our mistake. So then we got a result of 6. If 6 is correct, what result should we get? 0. I like that unison. See how that works? You don't have to do it that way. I'm just showing you what's possible. You just want to have some, you don't have to do it this way. You need to find your own way. You got to get intimate in your own kind of way. And it's going to be clear. Like when we get on the exam, if you ask certain questions, like how to use your calculator, or certain kind of questions, I'm going to know without even, I'm already going to know. But when I ask certain questions, I can tell based on the way you all respond whether you've been doing my work or not. And again, it's not really for me, it's for you. It's not me, it's not for me, it's for you. Because I already know this stuff. All right. Questions, comments, or concerns before I go forward? All right. So yeah, we checked it in. But yeah, when I do mixture problems, I usually use that technique. I say %1 times amount 1 plus %2 times amount 2 equals %final times amount final. And then I plug in each piece of information in the appropriate location. Usually by the end of that, it works. All right. So then we have a typed up solution here. Read the problem, 15%, assign variables. So this is the way they do theirs. This is fine. It's the same thing. You see, we had this equation up above, multiplied by the appropriate power of 100. Now, they kept their decimals. They decided to keep the decimals, and that's fine. You don't have to get rid of the decimals. I'm just showing you alternatives. You don't have to know all the routes. You just need one route that works. Just like in life, there's more than one way to skin a carrot, because I don't want to skin the cat. You ever heard the saying, there's more than one way to skin a cat? Yeah. So what that means is there's more than one way to the solution. I just don't want to harm a cat. Like, why would you want to do that? So that's why I say it's skin a carrot. It doesn't harm the carrot. Can you prove that it does harm the carrot? So I mean, I think there's a point to that, because some people use the train of thought, well, they eat veggies, it's okay. Some people eat veggies because, like, okay, eat it, like certain vegetables, you don't have to kill the plant to eat it, right? Like when you cut the leaf, it's like cutting your hair. It doesn't harm you. The plant is still able to live. Now carrots, that's different, because carrots, you're actually pulling it by the root. But you can cut the leaves off the carrot, plant the leaves, eat the carrot, and the leaves are still going to grow more carrots. So it's like, if you really want to play that game, you can actually eat the carrot without harming it. There is a way to get around that. But the cats and the animals and things you're eating, that's a whole energy thing. I'm going to let that be. But the same way there's more than one way to skin a carrot, there's more than one way to approach these questions. So you don't have to do it my way. You just need to, I'm just showing you alternatives for you to find something that works for you. Questions, comments, or concerns? All right. All right, let's see what's next. What's the time? So we'll go for about 20 more minutes, and then we're going to change the rhythm. We're going to change up some. We did all this. We checked it in the context of the original, so we'll let that be. I kind of want to do another mixture problem. Oh, so this is on investments. I kind of want to tell you this story. Story time. Now, I haven't been able to recreate it, but I know it exists because every time I go to study it, I find it. So when I was a student in undergrad, I was going to some award ceremony for some honor society, and they were doing a fundraiser. And this fundraiser was entitled the Infinite Scholarship. I'm going to use green for money, but it was entitled the Infinite Scholarship, right? So it went something like this: they were raising funds, and their target was $1 million for this scholarship, right? You know how it goes. And so basically, they had now at that time. I don't know if they still have this account. I don't even know if these accounts still exist. But they had an interest-bearing account at simple interest. It had an interest-bearing account of 5%. 5% as a decimal is 0.05. So then the way it works, so they generate the $1 million in any kind of way that they can, and they have an interest-bearing account of at least 5%. What's 5% of a million? So if we said 5 times a million, that would be a 5 with what, 6 zeros, right? But then we got to account for this 2 decimals. So what do? We dial the decimal what? Back by 2. So that's going to knock that off and knock that off. What's that number? 50,000. 5% of $1 million is $50,000 a year. If you had, so long story short, what that's saying is that if you have an interest-bearing account of 5% and your principal is $1 million, that means that you're going to get $50,000 a year. That was the plan for that account. So they had an interest-bearing account. So the idea was only touch the interest earned. So whenever they divvied out money, they would only touch the $50,000. They would not go beyond $50,000. So that means that every year they're guaranteed a full-time check. That's pretty much a full-time check. Just with that little setup. And I know people that have had millions of dollars. They've had access to interest-bearing accounts, but they didn't have this notion of living off the interest alone. With this setup, with interest-bearing account at $50,000 a year, and you only touch the interest, you have money for generations. That's why it's called the Infinite Scholarship. So I'm just saying this to say, when you all start making your 6 and 7 figure salaries, and you have access to interest-bearing accounts that have a decent interest rate, eventually we're going to get to a point where we can live off the interest, and then you'll have money for generations. You can do nothing and still bring in a full-time check. But if you're not aware of it, then you can earn the $1 million, and then easy come, easy go, and you can lose it. But if you have an account where you're only touching the interest, you'll have money forever. Go ahead. Now, when I went to Bank of America to inquire about interest-bearing accounts, they were quoting me something like 0.01%.
That's a little bit
too. So when you say percent, then that means move the decimal to the left twice. 00, come on, 01. So that's the kind of interest that they were offering when I went by the bank.
What about SunTrust?
I mean, you'd have to do your research. And like when I listen to people like Tony Robbins, they still talk about compound interest even to this day. So it's like apparently these accounts exist that have. And when I was younger, like when I was you all's age, there definitely were accounts that had 5% interest. Now it's much more difficult to find that right now, but I'm under the impression that they still exist. I don't really know. I'm just bringing it to your attention to go look for it. If you find any kind of interest-bearing account, especially that's 5%, hold on to it, because you'll have one part of the equation. The other part is you need the principal of $1 million. But with that combination, you can have money forever. As long as you only touch an interest earned, you'll never drop below, the principal will never go below $1 million, and you should continue to generate that money forever. As long as that account is open and active. Does that make sense?
I mean, it's a lot, but
Well, it's only 2 parts. It's a huge principal and an interest-bearing account of 5%. That combo equates to $50,000 a year. So as long as you don't spend more than $50,000, which is a full-time check, that's like a couple of thousand. If you're making $50,000 a year? How much is that per month? Divide by what? By 12. Hey Siri, what's 50,000 divided by 12? That's $4,166 a month. That's more than enough to have a place to live, a decent house, food, entertainment, whatever it is you want to do. $50,000 a year. Now this is just raw. I don't know what other kind of factors are factored in. This is more than enough for that. And in today's standards. So, if you're ever able to make that, it's just something to consider, something to look into. And, if you ever want to help out your dear old professor, I'm always going to be here in one form or or another. Questions, comments, or concerns? So it's just something to consider. That's all. All right. So now let's look at an investment problem. So like this is one way to do it. I don't know if I shared this with you all or not, but I've gone around. I'll go around the city. I'll go to different little art venues. Like one of them, I was at this place called Callenwall. Callenwall is like it's a mansion here in the city of Atlanta. It's right in the heart of the city. It's the mansion that was owned by the Coca-Cola, the president of Coca-Cola, the CEO. Callenwall. It's an inner city mansion, but it's like a museum now. And so it's like $5 admission. You know, it's just really inexpensive to go tour it. You can go on the premises. You can go on the property for free and just tour the property. If you want to tour the mansion, it's like $5. But when we went inside the mansion, they had artwork on display, and the artwork was something that was really simple. It was like one piece was just like a rectangular canvas. They put like a guitar across it, and they just painted the American flag over top of all of this. And this thing was on sale for like $70,000, $80,000. I was like, "Are you serious? Are you kidding me? I can make that. Like, you know, I can make this art." There was some other art that was simple. Other art was just strings thrown together, you know. But I say this to say, you can make this art. So it's a good idea to go visit art, you know, museums and things of that nature. See what people are paying for this artwork, and just start making stuff. Just make some artwork. Give me a moment. And so, like the second Sunday of every month is free admission to the High Museum of Art. And so you can see like some actual art that's on display and like think, okay, can I make this? And like some of the stuff you can actually make. You can make it. And you know, your work can actually sell for hundreds of thousands of dollars.
You said the second Sunday?
The second Sunday of every month is free admission to the High Museum of Art. And right before we started this quarter was free admission to the High. And I usually like to go. So anyway, I just say this to try to inspire you, you know, to just explore and see what you can do.
You said it's called
Callenwall. It's on Moreland Avenue. Callen. It's like Callenwode, something like that. Callenwall. Something like that. It's an inner city mansion. But don't worry about it. So I went into that story just to encourage you to, you know, see what you can create. You know, just become a producer and make some things. What's the time? All right. So we'll go for about another 10 minutes and we're going to change it up. So in this example, it says that an artist has sold a painting for $410,000. He needs some of the money in 6 months and then the rest in a year. He can get a treasury bond for 6 months at 2.65% interest and one for a year at 2.91% interest. His broker tells him that the two investments will earn a total of $87.61. How much money should he invest at each rate to obtain the desired amount of interest? Okay, so let's go back and organize this data. Now this is all simple interest, so we're not doing compound interest here. Yeah, so give me a color.
Go slide to the other slide. Oh, again. Green. I like
This one? I heard green. This one, right?
That's a mint green. That is not mint green.
You mean this one? You mean this one?
What are you doing?
I heard mint green. I don't know.
That's it.
Okay. So now we're going to say that I equals PRT because we are still doing simple interest. But he wants to divvy up this money into two accounts, right? So we want the interest earned on account 1 plus the interest earned on account 2 to equal the total interest. I'm trying to see if I can do this the same way. I think I can do this the same way I did the last one. So let's do the following. Not in the sense of what we mean by compound interest. We're just saying we're doing simple interest on two separate accounts, right? So let's see. Okay, so let's do this. Principal times the rate times the time is going to be our interest, right? We have account 1, right? And then we have account number 2, right? Number 2. that was a Gold Member reference. Sorry, Gold Member. Number 2, will you please? You know, he had his henchman. And the second in command, he kept referring to him as number 2, you know. So it was a running joke, you know, because yeah. All right, so let's make a table like we did in the last one. Let's make a table. Yeah, it's bad. I just do that to change the energy and to keep the energy going, so it's not so boring. Oh, I just missed it. All right. Because if I talk with my Clear Eyes voice, so first we're gonna make a table, and oh no, I'm still messing it up. I can't do it. All right, all right. So we got that, and we're gonna just make a table like we did last time. Well, let's see. I don't know. I mean, this is just me. It's like, when you want to make sure that you can do all this stuff. All right. Let's see if we can fill in the table. Let's go back. It says he sold a painting for $41,000. He needs some of the money in 6 months. How can we $410,000? How can we capture that 6 months? How do we convert that to years? 6 over 12, right? Because it's 12 months in a year. So let's let that be account 1. So that time there in years is going to be 6. We're going to say 6 over 12. And then the other one, what's the time? Time. One was 6 months, the other is a year, right? The other is a year. So again, this has to be in years, the units of years. Let's see what else. He can get the 6 months at 2.5 is his rate, 2.65%. What's that as a decimal? Uh-huh.
2.65 as a decimal? 0.0265.
Okay. 2.65%. The percent symbol means per 100. We divide by 100, you should get this result. Move the decimal to the left twice. The other one, what's that? Tell me about the other one. 0.0291. There was a question earlier. I don't know if I ever came to it or not.
Oh, I answered it myself.
You got it?
But if it's a decimal, you divide, and then if you're trying to find decimal, you divide and find
So this symbol here, it means per 100. So that you can just replace the percent symbol with per 100. So it just means divide by 100. So move the decimal to the left. Remember that, the whole thing?
Yeah.
That symbol, look at it as per 100. All right, what's the time? Come on. Okay. So let's keep going. Let's keep synthesizing the information. And let me go ahead and mark that. This means, we're going to look at this as per 100. So that means divide by 100. All right. It says the two investments will earn a total. We're going to come back for that. Can you tell me about the principal? How much is, it says how much should be invested at each rate. So if it says how much, that means that needs to be our X, right? So X is going to, where's the X going to go? Okay, for account. Okay, we can let account 1 be X. But if account, man, thank you, train. Oh my God. I mean, it's like this every day. Like it just comes to here blaring, distracting me. Okay, so if we're gonna invest X amount of dollars into account 1, how much is going to account 2? So what happened? Where's the amount of money coming from? The principal. From what's the principal? What number? 410,000, right. He has the 410,000. He's divvying up between the two accounts, right? So he's going to put some unknown amount into the first account. So how do we know what's left over?
That minus it's the first number.
Yeah, the 410. So we're going to say the 410,000. We're going to say minus X. Let me do it like this. Does this make sense? Yeah. Are we all aboard or all board? I made a chart. I don't remember. I made a chart, and I'll keep going back and forth. I'm reading, and I'm filling in each piece of information.
No, I was talking about like
The technique. The technique comes from repetition. Repetition. Okay, so there's simple. Oh, well, you mean the Oh yeah, repetition is the same thing. Repetition. So now the interest earned on account 1, PRT. What do we do with these numbers? We multiply. Okay, if I were to say we don't die, we multiply. What movie am I referring to? Oh, you actually know that one. Wow, okay. Y'all haven't been getting my movie references, so I didn't think y'all would know that. Yeah, that was Baby's Kids. Well, it's random, but it's inspired by the stuff that we're talking about. You know, so that's usually where it comes from. But it's not really random.
No, when you say it,
yeah, that's true. But again, it's inspired by whatever we're talking about. Okay, so the interest earned on account 1 is now going to be we're going to have x times this 0.0265 times the 1/2, the 0.5, right? Let me kind of do the same thing I did with the other. All right, and I'm going to shrink this down and put it back. 6 divided by 12. Come on. All right. Is that okay for the interest earned on that first account? Can you tell me about interest earned on the second account? Yeah, the one, yep, minus that, right? So this is going to be the interest earned on the second account. Now, there's one more piece of information we have to bring it on home. So we have the interest earned on the first account, interest earned on the second account. What do we know about those two together? So those two the interest earned on each account should total $87.61. So it should be equal to $87.61. So I want a copy of this guy. I'm going to copy, paste that one, and this one. I want to copy, paste. So if we say that first one plus the second one, should give us that. I don't even know what I did with that. Okay. So the interest earned on the first account plus the interest earned on the second account should equal to $87.61. Does that make sense? We'll recap it. Another opportunity, only if you have not already gotten bonus points. So first person to give me the correct answer, and you might be ready to walk me through it. All right. So now we have one equation, one unknown we can solve. How do we get rid of the decimals? Left and right by 1,000 in this case, right? Because of the 3 decimals. So we're going to say the left side by 1,000 and the right side by 1,000. When we do this, the 1,000 goes with, oh wait, 1,000's not going to work. 10,000, right? Because there's an additional 0. Additional decimal. If we said 1,000 is only 1, 2, that's still not going to work. 1, 2, 3, 4, 5. We need this because the 10,000 would have only squared that one away, but then this one would have still been a decimal. So we needed another 0. Don't worry. Let's see. So 1, 2, 3, 4. Yeah, you gotta work it yourself. You gotta do it yourself and do whatever's comfortable for you. Again, you don't have to do it this way. But when I do this, I'll get 265, I get 5, and I get x. That should be correct. We got 1, 2, 3, 4, 5 zeros. 1, 2, 3, 4. So that becomes 2910. This stays. Again, like I was saying, this takes practice. So don't just take what I'm doing. You want to make sure that you can do it yourself. I got 5 zeros, so I get my 8761. And this may not have been the best way to go about this. 1, 2, 3, 4, 5. This is just one technique. You don't have to do it this way.
Oh my goodness.
Let me finish it out. Let me finish it out. Unless, did somebody get a result already?
No, that was
Copy. Paste. I want to clear. Yeah, it's just one of those things where it kind of gets like that. Let me keep going. So we got 5 times this 265. 265 times x. I'm going to distribute this. Let's see. Oh, that's getting worse. So what I'm going to do, I'm going to leave it as 2910 times the 41. I'm not liking that. Got to be neat. 41 0 triple 0. I'm going to leave those, and then it's going to be minus the 2910 times the x, and then the right stays as is. 87 610 triple. Nope, I didn't do that right. Hang on. 1 2 3 1 2 3. There it is. 100 and then triple 0. Okay. Let me try to bring it on home. Let me finish it out. Did you get a result?
No.
Let me finish it out. And then we'll entertain questions. If I combine like terms, so I'm going to kind of do this in one step. You kind of got to do this whatever works for you. So what I'm going to do, I'm going to say this 5 times this 265. I'm going to say minus the 2910. All of that's times x. I'm going to say equals this 876 100 with the triple 0. That should be minus 2910 times this. I'm keeping these numbers. You don't have to do it this way. Let me finish it out and see if it works. So ultimately, we should get 876 100 triple 0 minus 2910 410 triple 0 over 5 times this 265 minus the 2910. Let me crunch this number, see if it works, and we'll have a discussion. I know it's a lot. You don't have to do it this way. You just got to find something that works for you. Let's see. Here's the moment of truth. The top is 876 100 123 minus the 2910 times 410 triple 0. That should be the top. Divided by 5 times 265 minus the 2910. Okay, I put the whole thing in there. We're saying x should be amount. So now, if we're looking for an amount to go into account 1 and we started with 410,000, what kind of, let me see, is this a reasonable answer? We got a result of, we got that x should be, what is that, 200,000. Is that reasonable? Is that reasonable? Because remember, we started with how much? 410,000, right? So if we're putting 200,000 into the first account, it sounds like we're going to put 210,000 into the second account. Okay, let me just look and see. In red, they did the table, which is fine. You still got to crunch the numbers, so it takes practice. 200,000 is correct. It's correct. That was just the way I do it. You don't have to do it that way. I think the book does that a little different. They didn't get rid of those decimals. They multiplied the numbers out.
Yeah, that's what I do.
And that's fine. I'm just saying sometimes the decimals make it worse. So I just want you to be aware of different routes. You choose whichever one works for you. Okay? You choose whichever one works for you. Because keeping the decimals, sometimes that is easier. In this case, I think keeping the decimals was easier. But sometimes keeping the decimal makes it way worse. So I just want you to be aware of the technique of getting rid of the decimals. Okay, now there was a question in the back.
I was just going to ask you multiply the
Mm-hmm. Why did I do? Why did I multiply by the 100,000? Why did I do the 100,000? Okay, because at first I don't want to leave. Give me a color. Blue. I need something bright. I think this will stand out. Okay. So at first I was going to do 1,000, think with this number in mind, but I thought it was only 3 digits behind the decimal, and it was actually 4. So then when I saw it was 4, that made me change it to 10,000. Now if I multiply by 10,000, this is no longer a decimal, but then this still will be a decimal. So then I needed another 0 to account for this one. So that's why I chose 100,000. Does that make sense? So 10,000 went here, 10 went here. If I'm distributing, it should be this times 100,000. So I had to move the decimal 1, 2, 3, 4, 5 times. So with this one, when I distribute, I had to move the decimal 5 times. So 1, 2, 3, 4, and then I had to move it one more. That's why I got the 2910. Okay? I know that's a little bit verbose. It's a little bit hard to follow. I just want you to practice, clearing out the decimals and maybe practice doing it while keeping the decimals. And you decide which route you want to take, whichever one works for you. You decide. So this one is here. This is already loaded into Moodle. You actually already have a copy of this. And all the stuff that you see me writing on the board, I'm going to load it into Box before I walk out of the room. So you already have a copy, and you're going to get another copy. You're going to have it. It's going to be there. Okay, is this okay? Questions, comments, or concerns? So, just choose whichever one works for you. And they're both valuable. They both work. It's just sometimes one is easier than the other and vice versa. All right, I'm going to finish out this section. We got that result. We checked it in the context of the original. How many more? Okay. So a math model is an equation or inequality that describes a relationship between two quantities. A linear model is going to be a linear equation. This example, I'm going to leave this as an exercise. Okay, I'm going to leave this as an exercise for you. Okay. All right. So with that, we finish out section 1, 2. I'm just not ready to have an exam next Wednesday. Monday's a holiday. We're not done for the day. I'm just kind of thinking out loud. I really want exam 1 to be over chapter 1. I really wanted it to be next Wednesday. We're just not going to be able to do that. So I'm not going to do exam 1 next Wednesday, but we're going to keep moving forward with the material. So for the remainder of today, we'll just kind of relax. We can either work problem sets. I don't think I have any videos that I wanted to show that's pertinent. Okay, I got a riddle. What did we do last time?
The dollar.
We did the dollar. And we talked about it, right? I'll come to that in just a moment. A good riddle. I got a math poem. Did I do the math poem with you all? I don't have another math riddle. No. I got a poem though. I'll do this poem. Just because it's Friday and I want to kind of lighten it up a bit. Pardon? Yeah, I know it's like that. It's because I'm plugged into this. I'm streaming into the laptop and to the web. Yeah, we're still live. Yes, hello, YouTube. No, but yeah, if it's 100, yeah, I would definitely unplug it. Yeah, I know about the battery thing, but I'm streaming and I don't know what else to do. Okay, so this is a math riddle. Math poem. And I came across this from one of my supervisors. We were having a math conference, a symposium, and he just gave this as an introduction or as something interesting. Let's see, it goes like this. Have I done this with you all? It's a poem. Can I get a volunteer to try the poem?
Is it supposed to be converted into words or just solid?
Can I get a volunteer to attempt the poem?
No. How do you?
Wait, you wanna give it a go? Give it a go. What's your last name? Okay. Did you sign the attendance? Did you write in blue? Okay, I see it now. I couldn't read it. Okay, let me see your attempt at the poem. Out loud. Just it's something you say out loud.
Is that a 7?
Yeah, that is a 7.
To get rid of the 7, multiply it on both sides.
No. Just read it. It's a poem. Read it. Just read it. Just read it. Yeah, just read it.
12 plus 144 plus 2.
Keep going. It's okay. Keep going. It's okay.
Time plus 3 root 4 divided by 7 plus 5 times 11 equals 9 squared plus 0.
Okay, wait. Do y'all feel the ground shaking right now?
Yeah.
Is that an earthquake or?
It's the train.
But the train's not out there.
So that's not just me.
No, I'm sitting here like shaking.
Everybody was shaking the table.
No, I think it's a minor tremor. But no, that was a good attempt. That was a good attempt at the poem. But it goes like this. So the poem goes like this. No. Give me a color.
Blue. No, do that light purple. Do that light purple. The lavender. Slide over. Right there.
All right, and then we'll go like this. Actually, I didn't mean to do that. Okay, so the poem goes like this. A dozen, a gross, a score, plus 3 times the square root of 4, divided by 7 plus 5 times 11 equals 9 squared, and not a bit more.
Okay.
Did you say you hate everything about math? But no, math is life. Math is life. That was a poem. So Miss, you said Wagiti? That was worth 5 points in my book because you volunteered. Math poem. Oh, okay. What's the time? All right. So yeah, we only got about 10 minutes. So we can I'm gonna stop the stream. Let me see if there are any announcements. So now originally I wanted exam 1 to be next Wednesday. I'm not gonna do it next Wednesday. I probably won't even do it next week. I'll probably do it the following Monday. Now with today we finished out section 1, 2. I really want exam 1 to be over chapter 1. Okay, so yeah. So now the way the homework works, you have 1 or 2 options. So the way I'm going to check it, I need you to bring in your homework notebook. I need a notebook, a neat notebook that has your homework. You're going to bring it in the day of the exam. You have 1 or 2 options for the homework. You can either do every other odd out of the back of each section from the book, or you can do the work that's on My Math Lab. My recommendation is to work on My Math Lab. If you want to use My Math Lab, we do have to use it for free. The free technique I told you about. You just have to print it out, write it down, and have it. You just want to have a notebook where you can easily find each question. Keep in mind that on My Math Lab, there's a question ID associated with each question. So it's telling you where in the book the questions are coming from. It'll say 1 point, whatever. And it's telling you chapter 1, section 1, question 26 out of the back. Okay? So to access it, what you're going to do is go to Moodle, click on the link. And we'll look at it in just a minute. It should put you directly into our My Math Lab account. When it prompts you to pay at the bottom, you want to click on the get 14 days of temporary free access. It'll give you 2 weeks of free access and use the whole technique I gave you for that. Go ahead. That's fine too. That'll work as well. Yeah. Okay, so I know I need to check the link for My Math Lab. Anything else before we part? Okay, so we're not leaving. I'm just stopping so we're not interrupting the other class. So we still got about 10 minutes. I'm going to stop the stream.